Hello, my name is Jordin Marshall from The Ohio State University, and this recording in my absence is to provide you with information about my poster, which is entitled Diurnal in Spatial Variations in Extracellular and Pericellular Content in Nucleus Pulposus Tissue. So just to give you some background to understand this study, so we are focusing on the intervertebral disc, which is the fibrocartilaginous organ that sits in between the vertebral bodies of the spine. And it's previously been reported that the cells in the nucleus pulposus, which is the center gel-like region in the disc, these cells have a specialized pericellular matrix aside from the extracellular matrix. And the pericellular matrix immediately surrounds each cell, aside from the bulk extracellular matrix that separates cells from each other in this region of the disc. So it's previously been suggested that the fixed charge density, or the sodium content, which is what we're measuring in this study, is different between the ECM and the PCM. And currently, the methods that are used to measure these differences, they don't have the ability to get down to the super small scale that we're looking at in this study. And so this study employs the use of a technique called laser ablation inductively coupled mass spectroscopy, or LAICPMS, which is able to assess intratissue sodium without requiring equilibrium dialysis, and it's also able to assess these sodium measurements at a micrometer scale. So what we are proposing to do in this study is to determine the variations in sodium content between the ECM and the PCM. And then we're also trying to determine the variations during a daily cycle. So as you move throughout the day, your disc is compressed, and then as you relax and sleep at night, your disc is still compressed, but not as much as it is during the day. And so we believe that the fixed charge density is higher during the day than it is at night. So how we carried out this study is we obtained bovine caudal motion segments, and a motion segment is just a disc bone segment, and we loaded them diurnally over a 40 or 48 hour period using a 16-hour daytime load and an 8-hour nighttime load. And we did these measurements in a heated water bath. And immediately after the tests were finished, each segment was stopped at either the end of the nighttime load or the end of the daytime load. And following the mechanical testing, the motion segments were frozen in place. And then the discs were extracted, cut in half, and then sectioned in 10 micron thick sections along the open face. These sections were then fixed to a slide, and then they were ready for our laser ablation measurements. And so before we actually did our laser ablation measurements on our diurnal tissue cells, we first tested our consistency of our measurements by picking a region of tissue that seemed to be of uniform thickness. And so we drew an ablation line, which is 6 5 by 5 micron spots. And so we drew 3 different lines, so 18 measurements, and all of those measurements were within 22% of each other. And so when we got to our daytime and nighttime samples, so we pretty much did the same thing, but we actually identified a cell, and we drew our ablation line from the extracellular matrix to the pericellular matrix, and then from the pericellular matrix to the extracellular matrix. So 2 different lines per cell, so 12 measurements per cell. And so helium gas carries the ablated tissue from the ablation chamber to the mass spectrometer, and then the sodium content from each ablation region is measured over time. And the total sodium content of each ablation spot, which is calculated by summing the sodium signal over time, was normalized to the ablation volume. And then lastly, the normalized sodium content from the ECM and PCM at both the day and the nighttime deformation were analyzed via a repeated measures 2-way ANOVA. And so for our results, what we found was that there is a significant effect of diurnal time on the sodium content within the tissue. And there is also a significant effect of the ablation region on the sodium content within the tissue. So we are seeing a difference between the diurnal time in the daily cycle, and also the spatial variations between the ECM and the PCM. So to conclude, as I just said, our results demonstrate that there are spatial variations in sodium content between ECM and PCM, as well as in different points in their cycle, in the diurnal cycle. And also, these are the first measurements of their kind in the PCM in Nucleus pulposus cells, so that's pretty exciting. And our results also kind of match up or are similar to previous estimates of fixed charge density in the PCM using charge-sensitive stains. And so overall, this technique uses this study uses a novel technique that's able to give an accurate spatial measurement of intratissue sodium on the micrometer scale, which can allow studies on spatial variations in tissue composition and how they change with the disease and how this may impact disc cell function. So with that, I will thank you for your time and thank you for your interest in my poster.